Next, before we talk about a 30, 60, 90 triangle, I want to talk to you about tangent values. Okay, fundamentally, we're going to go back and we're going to talk about the fact that we know the sine of theta is y over r, and we know the cosine of theta is x over r. We also know the tangent of theta is y over x. I want you to notice something. Is that the same value algebraically as that right there? Is it true that y over x over r algebraically cleans up to y over x? It's absolutely true. Notice that's the sine of theta. That's the cosine of theta. So we're going to find our exact value angle measures from the unit circle for tangent by taking the ratio of the sine of that angle measure over the cosine of that angle measure. That's how we're going to come up with our tangent values for our unit circle, for our exact values table. Well, here is the cosine of 45 degrees. There's the sine of 45 degrees. So the tangent of 45 degrees has to be the sine value, which was root 2 over 2, divided by the cosine value, which was also root 2 over 2. So the tangent of 45 degrees has to be 1. And we could continue to do that all the way around the circle. Let's do that for 90 degrees. There's the sine and cosine for 90 degrees. So the tangent of 90 degrees is the sine, I'm not going to write it, I'm just going to write the value. I'm getting it from right here. It's the y-coordinate to that point, over the cosine of 90 degrees. Oops. What does that mean? Well, for those of you that have had trigonometry, you recognize that the tangent of 90 degrees is undefined. And there's why it's undefined. It's undefined because we can't divide by 0. Cosine of 90 degrees is in the denominator for the tangent of 90 degrees, and it equals 0 at 90 degrees. So tangent of 90 degrees is undefined. So let's continue to go around here. Let's find it for 135. We'll find it for 180. Find it for 225. Find it for 270. And find it for 315. And by it, I mean tangent. So the tangent of 135 degrees, remember the coordinates of this point are negative root 2 over 2 and positive root 2 over 2. So we have sine over cosine, that's negative 1. The tangent of 180 degrees is sine over cosine. It's perfectly fine to divide by negative 1, so that exists, and it's 0. The coordinates of this point are negative root 2 over root 2 for both coordinates, for sine and cosine. So the tangent of 225 degrees is positive 1. For 270, the tangent of 270 degrees is the sine value at 270 over the cosine value. Again, that's why the tangent of 270 degrees is undefined. The coordinates to this point were positive root 2 over 2 and negative root 2 over 2. So the tangent of 315 degrees is negative 1. And we could even do the tangent of 0 degrees, which will be equivalent to the tangent of 360 degrees. They're the same angle. is going to be the sine value over the cosine value. Both of those are going to be 0 over 1, which algebraically is just 0. We're going to take the work that we did with our 45, 45, 90 special triangles and the quadrantal angles, and we're going to build on more exact values based on 30-degree angle measures and 60-degree angle measures. We're going to do that by going back to geometry, talking about our special 30, 60, 90 right triangle that we learned in geometry. We have a 30-degree angle, we have a 60-degree angle, and of course we have our right angle in our triangle. We know that the shortest side to any triangle is always going to be opposite the smallest angle measure. So we know that that's going to be the short side. The other leg, every triangle has two legs. The legs make up the right angle. The other leg has a relationship. We call this the long side, but it has a direct relationship with the short side of the triangle in that it is square roots of 3 times the length of the short leg. And our hypotenuse, which is always opposite the right triangle, has a direct relationship with the short side of the triangle as well in this special right triangle, in that it is always 2 times the length of the short leg. So bringing that information from geometry into our right triangle, we're going to call the length of the short leg, we're going to call that length x. So that we know the length of the long leg has to be square roots of 3 times x, and the length of the hypotenuse has to be 2 times the length of the short leg, or 2x. So now we want to find the 6 trig ratios for 30 degrees, and then after that we'll find the 6 trig ratios for 60 degrees. So let's do that. The sine of 30 degrees. Here's our 30-degree angle measure. This time the short leg is the opposite side, and the long leg for 30 degrees is the adjacent side. And again, here's the hypotenuse. So we know the sine of any angle measure is always opposite over hypotenuse. Algebraically, the sine of 30 degrees is 1/2. The cosine of 30 degrees is adjacent over hypotenuse. So we know that the cosine of 30 degrees is square roots of 3 over 2. The tangent, you have more than one way now to find tangent, was opposite over adjacent. Or additionally, was the sine of 30 degrees divided by the cosine of 30 degrees. So it was 1/2 over root 3 over 2. Algebraically, that cleans up to, not surprisingly, the same value. It better be the same value. So there are our 3 basic trig functions. It's fairly easy to find their cofunctions. The cosecant of 30 degrees has to be 2. The secant of 30 degrees has to be 2 over root 3. For those of you that have had trig, that's what it looks like when we rationalize the denominator. And the cotangent of 30 degrees is root 3. I guess I better write this as you're used to seeing it as well. Let's look at and find the 6 trig functions for 60 degrees. Here's our 60-degree angle. Here's opposite. Here's adjacent. So the sine of 60 degrees is opposite over hypotenuse. The cosine of 60 degrees is adjacent over hypotenuse. The tangent of 60 degrees is sine over cosine, or opposite over adjacent, which we'll clean up to root 3 either way. The cofunction to sine is the reciprocal. You can check me on that algebra. It does clean up to that. The secant is the reciprocal of cosine. And the cotangent is the reciprocal of tangent. And those are all of our exact values. That's the entire set. What we did on the last video and these 12 that we just went through are the entire set of exact values. They are much easier to locate in the plane. We're going to take that 30-degree angle measure and we're going to put it in our XY plane. We know all about our quadrants now. We know all about the signs of the coordinates of our points in each quadrant now. We know that we can reflect things around the surface of this unit circle. R is still 1. We're still in the unit circle. And so we can use the unit circle to help us find other angle measures besides 30 degrees, just like we did 45 and 135 and 225 and 315. You can do the same thing here. Let's reflect this point directly over the y-axis. We know now that we are dealing with the same magnitude, the same horizontal or x distance, but now we are on the negative end of the x-axis. And we know that we're still on the positive end of the y-axis, and we have the same magnitude there. So this is 30 degrees. If we go another distance here, another way to do this maybe a little easier is this angle measure right here has to be 180 minus 30. So there's 150 degrees. We could do the same thing here. We could reflect that point over the x-axis. We know that we have the same negative x value and we have the same y magnitude that we have reflected down here, but it's now on the negative end of the y-axis. So we know the coordinates to this point have to be negative root 3 over 2 and negative 1/2. This is 180 plus 30 degrees, this angle measure. So this angle measure is 210 degrees. We can take this point and reflect it over the x-axis, or this point and reflect it over the y-axis. That gets us to this point in the plane. We have the same y distance that we've been working with, but we know we're on the negative end of the y-axis. We have the same x distance. We're on the positive end of the x-axis. So that has to be the coordinates to this point. We know that 1 full revolution is 360, and we're stopping 30 degrees short of that. So that angle measure has to be 330 degrees. So we can use the coordinates of those points to find our sine and cosine of several other angle measures in the plane. Those are called coangles. We use 30 degrees, 60 degrees, 45 degrees, and so on as reference angles to help us find the measures of other angle measures in the plane.